Getting started. All right. Okay, so it's 12:01. Hello, everyone. I'm glad you could make it today. On behalf of GTS Group, ECG, PICE, Seek, Dimension Software and Texture, we would all like to thank you for sparing your time today in attending the second of our Smart Pi webinar series. As we have a fairly full program today, or actually it's a very full program today, I'll just give you a brief overview shortly on GTS. We'll just go through the agenda and we'll have some housekeeping items just to get things started. For those of you that don't know me, my name is Steve Hoffman. I'm the Director of Sales and Business Development for the GTS Group. I've been with GTS for nearly 3 years now. Some of you may know me from when I worked at OSI Soft, which I was there for 17 years prior. Okay, today I hope you can see our screen. It's really, as I said, the second of our Smart Pi webinar for electricity generation and term management, distributed energy resource management. Another thing that you may not know is that we're celebrating our 10th anniversary today as a company. So the founders of GTS, which is Andrew, Gavin and Rob, who are still working in the company, started off 10 years ago, and now we're reaching around 40 people within the organisation. And from that, we are the most accredited OSI Soft Pi system in ANZ, with having 25 accreditations crossing a number of our engineers. Primarily what we look at doing is that we enable our customers to do better tomorrow with data. So you have a sizable asset within your Pi system, and with the Pi system and the functionality that can be derived out of the Pi system in conjunction with the partner technologies you'll see today, is that we're trying to leverage and create greater value and a quicker return on investments in associated with delivering solutions. So some of the things that we've learned over the last 10 years from a company's perspective is that we do and have developed some toolkits that we provide our customers, one of them being a synchronization application that enables you to synchronize between Pi AF and tag-based systems and AF environments, between, for example, test, dev, and pre-production into production. Also the ability to start synchronizing between SCADA and applications like Maximo, for example. We also provide a hosted environment relative to supplying solutions as a service for environmental, water and local government markets. And again, as you will see today, we're also aligning our capabilities with our partners in delivering solutions. The two that won't be going through today are PimSoft, which is a company that has a product called Signify, specifically for oil and gas and metals and mining for production and mass balancing. Power Runner, which primarily is for a transmission and distribution of energy and water, but it's really looking at large-scale deployment and leveraging the technology of the Pi system to fulfill those large applications around IoT and metering, as I said. One of the things that certain customers don't know is that we're the only OSI Soft partner that provides 3 levels of local Pi system support and partner support, categorized as ad hoc, business day and gold. So as part of that, we have now over 20 customers nationally which have undertaken the GTS program. I won't go through all these words in detail, but just to give you an indication, we'll have predicted through Chuck presenting the ability for predicted to be applied to asset and rotation equipment and allowing early diagnosis of assets which are in stress or fatigue or possibly failure. Post, we're looking at the ability to provide microgrid solutions which can be incorporated into a larger DERMS deployment. And one of those use cases is one where we've both worked together locally at Horizon Power in Western Australia. Seek will be providing, obviously, another analytical aspect to the full integration of the Pi system stack, and we'll be covering use cases associated with applications around the world So we thank them very much for the Seat guys to come in and participate. Dimension Software, which is our partners across the ditch, we'll be concentrating on downtime, process safety, alarm management, and the ability to incorporate a portal which is driven from your Pi AF infrastructure. And we'll book into the presentation with Texture. Texture is part of the GTS group, and they provide project delivery services that incorporate consultation through to project management, through to test management, through to change management. So what we're trying to do here as a GTS group is to ensure that we can provide the full gambit of a project to our customers, depending on what part of the journey they're in from a project perspective. From a housekeeping perspective, I don't think we'll have time for Q&A, but please send any questions through the chat. We'll get back to you with regards to responses to those questions. Today really is what I can call a tapas of being able to view and I won't say taste, but you'll be able to see various aspects in a brief program to see whether or not you want to go in and have a full meal associated with what we're providing. So if you have any requirements that you would like to investigate further or any questions, please give me an email under the Steve Hoffman GTS Group email account. And for others, the webinar is being recorded, so we'll be able to share that recording post-webinar, and you'll be able to share it with your colleagues as you see fit. All right, that really looks at the end of my input into the discussion. I'll hand it over to Chuck now from ECG, and he'll be presenting the predicted product and the use case associated with how that product's being used. Chuck, if you'd like to just share your screen, please. Okay, Chuck, we can see your screen.
Can you hear me now okay?
Yes, I can, Chuck. Thank you.
My apologies. It was not going off mute there. Okay, well, hey, thank you, Steve, and good afternoon, everyone. We appreciate the opportunity to present to you today, and we want to thank GTS for hosting this webinar, and also congratulations on your 10-year anniversary. So, little background on myself, Chuck Farrell, Vice President of Sales and Marketing. ECG is a software company based out of the USA. We've been a OSI Soft Pi partner since the late 1990s, and we partnered up with GTS in mid-2018. Our focus is around bolt-on software for Pi users in their Pi platforms, and we're focused on equipment and process monitoring, mainly in the area of equipment health monitoring and diagnostics, and then also on process visualization and notifications for Pi users. So today I wanted to touch base on condition-based maintenance use case around the use of predicted. And for condition-based maintenance, I'll just keep it short, it's CBM. And probably you're aware that CBM evolved over time from the reactive maintenance into preventative maintenance, and then into condition-based maintenance being CBM. Preventative maintenance was focused around time-based PMs, and CBM is based around condition-based health monitoring. And so the goal of condition-based maintenance is to preserve equipment integrity, and that's done through monitoring of the asset to detect for asset health changes, and then focusing on the maintenance activities needed to preserve that asset health. And that's traditionally done using inspections, non-invasive, non-destructive inspections called tech exams, and that could be in the form of infrared thermography, oil analysis, manual vibration rounds, and other inspection techniques. And one of them is operational performance, and that's where your Pi data comes in, and using that Pi data to ascertain equipment health. And with that, today we'd like to present the next step in the CBM evolution, and that would be where you involve the predicted solution And the reason we're showing it in this diagram where PredictIt's in the center and the CBM information's orbiting around it is that PredictIt can utilize your OSI soft PI data through PredictIt to do anomaly detection, but then we can also use all of your CBM tools to do advanced diagnosis of it. And also, you can very easily integrate new CBM technology that is coming online, every day as the digital transformation age continues. And with that, PredictIt can enable a more effective CBM program that's focused around equipment preservation and really, leveraging your PI data, leveraging your current CBM activities, and helping you to accurately recognize accelerated aging of the asset versus graceful aging. And so if you have a major asset that has a 10-year rebuild cycle, you want to keep it on that life cycle track so that you're not spending O&M and capital dollars prematurely and taking downtime and impacting your business plan goals. And so if you rebuilt that major asset, over on the left, the equipment health is 100%, if you look at my mouse there. And over on the bottom, we have the time. And so you're expecting that asset to go 10 years before you start hitting any alarms around the DCS system, PLC, SCADA. And if it accelerates, let's say in year 6, you start seeing these indications, you're now 4 years short of your goal. And so what we're trying to do with advanced CBM using your PI data and PredictIt is to catch these issues way up on the curve so that you can fix them while they're small issues and develop a recovery plan to get you back on a 10-year rebuild cycle. The way we do that is through using PredictIt with your CBM program. We're going to work with companies, we're going to work with you to deploy the system. GTS is our partner in Australia, and so they'll help you deploy the PredictIt solution. We will then go live with the APR technology. That is advanced pattern recognition. It detects very subtle shifts in equipment health. Once you have that, what we're trying to discern there is abnormal behavior from normal. Once we see abnormal behavior, we're going to help you diagnose it. What is the issue we're seeing? And we do that within our diagnostic reasoner, and it's called, it's in a shell called Bayesian network technology. It allows you to link symptoms and faults probabilistically together to analyze it and diagnose your equipment issues. We will work with you and the GTS team to deploy diagnostics that are make and model specific to your assets. So if you have a large step-up transformer that's a nitrogen blanket, oil cold, oil filled, force cold, we'll have diagnostics specific to that make and model. We do that by working with you, getting RCM data, FMEA reports, failure statistics, and we build what's called a CAN, Causal Asset Network. And you do this all within PredictIt. Once that CAN is developed, you can use it across your fleet. We use subject matter experts to help build these CANs, or you can do it yourself with GTS. And once that CAN is loaded into the diagnostic reasoner, you can go live. We bring the APR alarms in, and we also bring in other CBM data in those tech exams. So we're looking for real-time equipment health indicators that you can use in the diagnosis. And the overall goal is to develop a recovery plan and take action to get you back on that 10-year rebuild cycle. And so with that, I'm going to go through an actual example. We're not going to dive into the software due to limit on time, but I just want to give you a couple general concepts around anomaly detection. What we're going to do is for every sensor on your asset, we're going to build a virtual signal for it. The virtual signal is the expected value, and that's in red. The blue value, the blue signal is your PI data. And we will see predicted alarms over here, whereas over here, you're going to see DCS, PLC, and SCADA alarms over here. And so that's the early warning benefit. What we're looking to see is that the blue line is over top the expected value. And the expected value is generated based on its relationship to the other sensors in the operating state that that asset is in. Let's say 10% load versus 50% load. And so once you have these expected values, you can then start measuring statistically how different is it, and then alarming these anomalies. And these are things that an operator just does not have the accuracy to be able to detect because it's so subtle. But it is an accelerated aging event taking place that's going to take life off their rebuild cycle. As I mentioned, the next thing is the diagnostic reasoner. We're going to help you configure a diagnostic can for that asset. And it's a 4-quadrant system. In the top left are the faults that are typical for that asset. In the bottom right are the APR alarms, and they're considered observations. Once an alarm is triggered, it goes into evidence, the top right quadrant, automatically based on the anomaly detected. It will then force rank the probabilities based on what evidence is present. A lot of times you don't have enough evidence just with your PI data to ascertain the equipment fault mechanism, so you have to go to your CBM program and bring in your tech exam data. And these are just a matter of questions, true or false, yes or no. If they're true, then you can move those manually into evidence and it will reforecast what equipment faults are most probable using the Bayesian network technology. And so this is an example I'm going to go through. This is a pulverizer in a coal plant, and there's a reason we use it. I'll explain it here in a minute. I'm not going to dive into this network, but we take subject matter expertise, FMEA data, and we build this network. And this is locked in, and your inexperienced people 5 years from now can go and tap this expertise level that's constrained in the software and you have control of. And so we picked this pulverizer example for a reason. It's in a very hot ambient temperature, extremely loud environment, so an operator cannot ascertain the health of it by listening to it. It's got limited instrumentation due to severe duty, and it directly impacts plant production if it goes down. And so this is a 3-dimensional model of the 3 rolls crushing the coal on the bowl, and a gearbox drivetrain drives this from an electric motor. Some of these mills are 500 horsepower in size, so this thing's quite large physically. Here's a cross section. You can see 1 roll touching the bowl, and we're going to show you 5 sensors: the motor amps, the 3 rolls deflecting as far as movement, and how much coal's coming in here. And so anything in green is an anomaly, anything in white is clear. So we have feed rate, the 3 roll deflections, and mill motor amps. The first anomaly we got, and by the way, this is a post-mortem for a customer. First anomaly we got was mill motor amps are running higher than expected. We then got a second alarm a day later that a roll deflection was not moving. One of the rolls is moving too little. With that, we can go to our diagnosis tool and see that these moved into evidence, and we have some faults that are probable, but the likelihood's not high enough. We can then go to our CBM tools and look at what CBM questions have been set up that if we can validate, we can move those into evidence and reforecast what's likely. And this is called pursuing faults. You can actually do what's called differential diagnosis. And so the plant was able to confirm that a CBM tech exam question, pyrites with coal, was evident, and that it forced the fault mechanism into roll seized, which is a very serious issue. They're going to have to plan a 5-day to 10-day repair window for this piece of equipment. But now that they know this, they can still do it while the equipment's operating. They can line up material and labor ahead of time, fix the issue, and get back on a 10-year rebuild cycle. And so this mechanism allows you to receive, and I'm running short on time here, so I'm going to go through one more slide. But the amps, a second roll deflection came in and increased it from 75% to 86%. So we know we're on the right track. But what the story at the end here is that we're able to give 4.5 days notice if they were using this technology. They took the equipment off over here, which on a forced basis, this was a post-mortem, and they were able to plan this out if they had these tools available going forward. So to conclude my short presentation, we have these diagnostic cans built out for standard assets. We're working on the renewables sector right now with experts, and you buy these cans once, you deploy them across your fleet, the same way with the anomaly detection software, and you can operate your fleet with this advanced CVM approach. And so winding it down here, my last slide, we do, GTS is our partner. They'll help us deploy the software with you if you have an interest in it. We have AGL and CS Energy not too far from everyone that you can have benchmark discussions with if interested. So with that, I'll close and just want to say thank you for your time today.
Terrific, Chuck. Thank you very much. I know we're pressed for time here, but there's a lot of stuff we need to get to. So thank you very much for keeping within the time frame. Much appreciated. Okay, we'll have Michael from PICE now present.
Yeah, thank you, Steve.
So if you'd like to just take over the screen, that would be great.
Yeah, can you just confirm that you can?
Yep, we can see
my
your screen.
Great. Yeah, so my name is Michael Christopher. I'm head of software development with PICE, and appreciate the time here today from GTS. And yeah, so looking forward to sharing a bit with you folks today. So just to start out, we've got a nice picture here of our headquarters in San Diego, where PICE is based in San Diego, California. And we're actually looking at some equipment from one of our microgrids. Unfortunately, not one we're talking about today, but it is a nice example of our technology close to home. Just a second here. Okay, so just a quick agenda. I'd like to talk about PICE briefly and how PICE uses the PI system. And then I'd like to cover two use cases, two example projects, just to give you that taste of what PICE is doing, hopefully to intrigue you to learn more. So we really see ourselves as a technology company, and we see this importance of bringing the grid into the 21st century, bringing into the future. A big part of this is the role of renewable energy, and the risk that actually presents to the grid as you increase the penetration or the amount of renewable energy on the grid due to its intermittency, due to its changes with the weather. And so we believe that the application of our technology, the use of intelligent technology, can help bring this into reality. So our team has quite a bit of experience in this field. As with Steve, I'm actually a former OSI Soft employee myself. I don't have as many years as Steve under my belt. I've closer to 5 or 6, but that was my prior role before coming to PICE. And then, in fact, a lot of our team does have that PI system background. So our technology is currently deployed in about 800 megawatts of various projects around the world. We'll talk about a couple of those today, and also kind of the classification of our projects. And we bring an innovative approach. So we actually have a number of patents that have been filed and are pending around our technology. One of the key innovations is our use of synchrophaser technology. And if you haven't heard of synchrophasers, or sometimes called PMUs, or phasor measurement units, they are a way of measuring high-speed grid states. So think current, voltage, and other quantities like frequency that help measure the state of the grid. So we actually are using synchrophasers directly in our control and our solutions. And lastly, just want to mention our backing from Sempra Energy and Mitsui. So the foundation of what we do, as I mentioned, synchrophasers. I also want to mention that we are OEM'd with the PI system. So we come as a packaged product, which includes the PI system infrastructure, and we really use that as our core data platform. So internally, we're using PI Data Archive, we're using Asset Framework, we're using PI Vision as part of our solution stack. Of course, we have our own technology on top of that, using that synchrophaser data. But we do heavily leverage things like PI interfaces and some of the other PI system components within our solution. And that allows us to do things like quickly bring our solution to configure our solution for new sites. And we can make use of things like the C37 interface that OSIsoft offers to do high-speed reads of PMU synchrophaser data at 50 or 60 hertz, and use that for our control data. So another core piece of our technology is DERMS, and we'll talk a bit more about what we think of as DERMS, but it's basically it's a comprehensive way of managing a large number of DER. So really what the goal of our technology is overall is how do we fold distributed energy resources, or DER, into a solution that allows utilities and facility owners to get value out of those and allow the incorporation of renewable energy into their facilities. So our stack, we really think of our solution stack in kind of three broad categories. One of those is power plant control, and you can think of this as utility scale solar or wind, sometimes paired with batteries, but typically not operating as a microgrid, typically operating as a generation resource on the grid. And while we don't have time to really get too much into power plant control today, I will touch on one brief example. So then we also offer a microgrid solution, which is a high-speed control DER controller. This is typically offered with islanding capability so that the microgrid can operate independently of the grid if necessary. And we're typically targeting this at utilities, commercial, industrial, building owners such as universities and other campuses and communities. And then the last category of solution is DERMS. So again, DERMS is more of the umbrella solution where we actually bring together sort of all of our technology into one integrated solution for managing DER. That can include both customer-owned DER, such as rooftop solar, as well as utility DER. So you can kind of think of this as the holistic solution. As I mentioned, I wanted to give one quick example of a power plant controller. For those of you who aren't familiar with this type of diagram, this would be called a single line diagram. This is for a large 200 megawatt solar generating facility, where we brought our technology and did control of both voltage and power for a collection of 82 2.5 megawatt solar inverters paired with trackers and other technology to manage the voltage using cap banks and the real and reactive power support from those solar inverters. But the two projects that I really wanted to focus on today, the first is a behind the meter microgrid that we did for Portland General Electric here in the US. So this project was a public-private partnership. The goal really was to increase the resilience of this building in the community. And the drive is really, again, the incorporation of renewable DER to hit certain targets and providing services to the grid at large. So this particular solution is supporting the frequency and low voltage in the grid connected mode, and also when islanding can support a grid outage. By using the battery resources and the solar of the system. So this was built from a 250 kilowatt battery storage system, 300 kilowatts of PV, and a standby diesel generator that can help that system make it through longer islands. So then we built this solution with our microgrid controller. Of course, the Pi system built into that to provide the data collection and the control. So just to talk a bit about those capabilities, I have mentioned that we're doing high-speed control. So we're typically doing this at up to 50 or 60 hertz, depending on the continent that we're in. However, oftentimes the DER themselves do limit that to some extent, but the controller is more than capable of commanding the system at those high speeds. And that gives you a lot of advantages. So you can make very fast responses to changes in the grid, disturbances from loads or generation changes, or other things that are happening at a high speed. So we pair this high-speed control with an optimization, and that allows us to get economic benefits from the system as well. And of course, because we're built with Pi included, We can give insights to operators via dashboards and HMIs, give them insight into their operation. I think in the interest of time, I'm going to keep going. Just wanted to give a quick screenshot of one of our PiVision displays from this system. This is what we would call our faceplate, where we can control all of the different aspects of what our controller is doing. So obviously, I can't go into this in detail, but just want to point out that the controller is capable of managing the system through various different modes, whether that be the management of battery state of charge or real power flow through certain points in the network, or actually taking care of some of those objectives simultaneously through that high-speed control capability. So the second solution I want to talk about is our DERMS project with Horizon Power. So the picture we're looking at here is from the town of Onslow in Western Australia, and this is a 1 megawatt solar farm that's owned by Horizon Power, which is part of this DERMS solution. So just to give a few more details on this, this is a remote town. The town of Onslow is quite remote in northwestern Australia, and so all of the generation is done there locally. There's no transmission from from power plants remotely. There's no interconnection to a larger grid. So all the power there is coming from these 8 1 megawatt natural gas generators with an additional diesel generator. You saw that 1 megawatt solar plant, and there's also a 1 megawatt utility battery. And actually, the numbers are a little bit larger than this now on the customer rooftop solar, but 1.4 megawatts and counting of customer rooftop solar. So as I mentioned, the DERMS is really a comprehensive solution. So it includes our microgrid controller for managing the resources, the utility-owned resources, but it also includes up to 50,000 customer DER. We're currently up to several hundred for this one town, but the design of the system is such that it's intended to expand to multiple towns and include many more DER. So Horizon Power wanted to, keep their system reliable, and if possible, make it more reliable and integrate up to 4 times the additional renewable hosting capacity that they had previously at this town. Obviously, too, they want to make sure that they get the most out of those renewable assets and reduce their annual fossil fuel consumption. So I've included this just to kind of give what we see as DERMS, and we look at it as a holistic solution where you bring all of your DER under one umbrella to control them and manage them. And to do this, we bring a number of capabilities, from the ability to forecast the loads in solar to the optimization of the operating of the various DER to achieve the system objectives. We also have a network modeling component that lets us model the actual as-switched network in real time, and that's so that we can understand how the DER operating conditions will affect the network and potentially avoid issues with voltage or power limits throughout the network. And then we're actually leveraging the IEEE 2030.5 server, or it's also known as SEP2 server, which is a new standard protocol for communicating with DER. So that allows us to reach out to those customer systems and provide those control signals. And I'm running a little short on time. I think we're close to the end here. I just want to run through a quick example just to give you leave you with a visual. So I mentioned the optimization of the DERMS and the function that it's performing. So I'll just walk through a quick example here where we start with a load forecast. So I mentioned one of our capabilities is the ability to forecast that system load. So we take that load forecast and a solar forecast for the day, and we come up with what we call an optimal operating plan. And so this is in light of all the objectives that we want DERMS to achieve, and in light of all of the various DER resources that are under the DERMS control, we come up with this plan to achieve various operating objectives, and then we basically disaggregate that plan as far as what the solar and the battery resources are going to do, and then we send that out through various mechanisms, one of which is that 2030.5 server, but we have other ways of doing that as well, and we get that schedule and that plan out to the microgrid controller and out to the individual DER so that we can operate the system in the best way possible. And then we actually redo this process every few minutes in light of all the new operating conditions and various states of the system. So with that, I know that was brief, but I just want to thank everyone for your time, and thanks for your attention.
Terrific, Michael. Thank you very much. Just to save time, Will and Seamus, you've got the floor now. So if you'd like to share the screen, and we'll get started with your presentation. Thank you.
Okay, great. Thanks, Steve. Can you see my screen now?
Yes, I can.
Oh, super. And Michael, that was great. I really enjoyed the presentation and I learned a lot. So I appreciate that. And thanks, everyone, and glad to be here presenting. My name is Will Knight, and I'm responsible for our partner sales and support. And I'm joined here today with Seamus Cunningham. He's one of our principal analytics engineers and a group leader on our engineering team. So we're going to divide our time up as follows. I'm going to do about 90 seconds on slides, and then we'll spend about 8 minutes looking at some use cases in the software. So Seek is glad to partner with GTS as a software company. We rely upon partners for sales, implementation, and support. So we appreciate the partnership that we have with GTS. So a little bit about Seek. We provide self-service advanced analytics, what I like to categorize as past, present, and future insights. Seek enables your engineers and data scientists to explore, to cleanse, add context, and investigate their data. They can do ad hoc analyses on unexpected anomalies that come up. They can create predictive models across assets and processes. And they can even apply these models as new data streams in, whether from Pi, from other historian data sources, or even other contextual data sources that might be available. We're slightly younger than GTS. We've been around about 8 years, but we're funded by some key players in the energy space with Saudi Aramco and Chevron, and some key industrial providers like Siemens, and Cisco. So we're excited to be here and share a bit more about Seek. So when we think about some of the use cases, Seamus is going to touch on parts of several use cases from Duke Energy, from Avangrid, and from Depcom. And each of these customers extended the capabilities of their historians to include advanced analytics. And actually, AGL shared a use case at our recent Seek users group meeting, but it's not published yet. We hope to get that published in the near term, so you'll have access to that. Now, one will provide a snapshot of some of the Seek capabilities that these customers leveraged. You can get much more detailed information either by Googling Seek and the customer name that you see there, or you can visit the link at the bottom of the screen, and we either have links to the video or the printed case study that you can dig into a bit more. Final note, we're tightly integrated with the Pi system. I know a lot of the folks on this call are using Pi. And of course, we leverage the data in Data Archive, but we can also connect to and import and export event frames, connect to AF, and also Pi notifications. So we have some really nice integration with the Pi system. So with that, I am going to turn it over to Seamus, who's going to spend the rest of the time in the software. So with that, Seamus, let me turn my screen over to you.
Excellent. Without further ado, I'll take a look, live look in some of the software. So I'm going to just give you a feel for what our end users do. It's Seek is a browser-based application that's really built for our modern collaborating engineering teams. And so each individual user has full access to any of the connected data sources. So all the different Pi and AF servers, or if there are other cloud sources of time series data, so things like weather forecasting or other cloud native data sources we can connect into. And each user can create their own documents. So whether that's we have 3 document types that our users work with. We have workbench analysis, that's where I'm going to start. That feels a lot like an Excel replacement where you can do a bunch of ad hoc calculations and contextualization and model building. There's organizer topic, which feels a little bit like Word or Excel, or Word or PowerPoint, and you can kind of gather together all the different pieces of your analysis and tell a story about what's going on in your plant. And then finally, a data lab project. That's for the Python crowd, and that actually launches a Jupyter notebook that's fully hosted by the Seek system, and you can analyze any of your data on that's connected into your Seek system. So with that, let's take a look in. So this is a workbench here. And as you mentioned, we, as an end user, you have access to any of the attached signals. So if you know the cryptic abc123.pv names, you can type those in and pull those up quickly. Or if you have an AF system setup, we actually index all of those asset frameworks, and you can navigate down through all your different assets and pull in any of the signals on any of those systems. Final way actually is how I got this on here. We also, you can, if you got a CSV file just sitting on your desk, you can drag and drop that CSV file right through your browser and actually integrate that with all of your live connected data as well. So on the screen, we just got some quick data from gas turbine here, and Seek enables all of your end users to have a huge suite of tools to analyze this data. And that goes from contextualizing it, so just finding periods of interest, and that can be as simple as what I'm going to do here, which is just finding when the turbine's actually operating, all the way down through much more advanced kind of pattern matching systems. So this will feel, for those of you who are very familiar with event frames, this will feel a little bit like an ad hoc kind of user generated version of event frames, where users can create searches and highlight across the top of the screen any times that search was true. And we can use these capsules. You can combine a bunch of them together to find, when the turbine was running and we're in a weather pattern or something like that. But you can use these contextualizations to filter down your visuals to show, for instance, only when the system's actually operating, or if you want to, for instance, find system startups, and you can find, the first 2 hours of every system startup, and see how all of your turbine startups look relative to one another, or overlay them to get a sense of how all of the different startups might be similar or different from one another. A lot of quick ways you can use the contextualization to find interesting things inside your system. But most importantly, you can also use it to create and contextualize how the system's actually operating. So you can really go find those gold nuggets sitting inside all the squiggly lines. So to do things like figure out, how long each of those turbine ramp ups took, or what the actual, whether it was a cold start or a hot start, and quantify how often any of those things are happening. Another kind of quick thing I'll just show in the tool menu is our model building. And so you also see me using the journal steps here. This is a quick way you can capture individual pieces and parts of the story, but you can capture, different visuals that help tell how you got from the raw data all the way through the calculated items. And one really nice tool we have in here is a really nice multivariable regression model. So again, any of the kind of model building that all your engineers are probably doing in Excel right now, you can do live on your Pi data and project it out into the future. So real quick ways to build contextualized multivariable models to evaluate how well those models are doing, and to see how your system is currently operated relative to that modeled performance. So a lot of really nice easy point and click tools that take care of 90% of the workflows, but we realize we're not going to build point and click tools for everything everybody wants to do. And so we also have a really nice formula language in here that codes exactly like Excel and has about 300 different functions that everyone should feel nice and familiar with. Things that Excel has and things you wish Excel always had, like derivatives and a bunch of different documentation that, so it's nice, easy self-service ways to create live virtual Pi tags. So again, users can take all these different tools to perform live calculations on their data. All of the calculations and models are again connected right to that snapshot data. So you can run any of the historical stuff live on about 5 seconds behind where the Pi system sits. And finally, I'll just, before we go and wrap up a real quick short introduction, show you what a topic might look like. So these organizer topics can be really great at wrapping up a bunch of different analytics to give a high-level overview about how a site is operating. So you can create live updating graphics that have a bunch of different, that wrap up a bunch of different analytics. Things that might be, for instance, where a particular pump is operating relative to its pump curve, or a predictive model for how a heat exchanger is performing and when next maintenance on that particular heat exchanger is going to need to be done. Or more sophisticated things like showing, for instance, how this particular turbine startup is similar or dissimilar to all the past, and if it's outside of its normal range of operation. So a ton of different ways to help tell the story of how your plant is operating, and again, get people out of spreadsheets and PowerPoint and into a live system they can collaborate with the rest of their teams on. Excellent. Thanks for a quick tour, Z.
Terrific, Seamus, and Will, thank you very much for your presentation. I'd like to now pass it on to our friends at Dimension Software, Paul and David, and we'll get started with your presentation. Thank you.
Thanks, Steve. Dimension Software. So I'm Paul Garnham. I'm the Business Development Manager for Dimension, and I've got with me David Barker, the Founder and Technical Director for Dimension. We've been around for around 12 years, and we've got two products, Asset Intellect and Alarm Sentinel, that we'll be highlighting today. Our products are used across all of the major industries that we come across in the industrial world, and our products are used throughout the world. It's browser-based, and it's a configuration-based software, so it's ideal to make it easy to use and quick to use. It's Pi asset framework integrated, and allows you to visualize multiple platforms within the one environment, and that provides full visibility of your operational data, so moving from one system to another in the right context. Helps you to consolidate your business intelligence tools. It's a flexible and configurable architecture. So the idea is that you're able to fully leverage your existing investments without recreating data in other places. We access it from its source, and I think it allows you to replace some of those legacy databases and spreadsheets with the likes of Seek, where we're pulling that data into our system, and likewise for the Predictic and Pice, we're all able to bring together in one place. And I'll pass across to David to run through a quick demo.
Very good, thanks Paul, and thanks Steve for the invite to the webinar. So this is Asset Intellect. Again, it's browser-based, HTML5. On the left-hand side is the Pi asset framework. So it's not a copy, it is the asset framework. We can bring multiple AF structures in here. The concept around it is to bring in, say, an element, let's say a fleet overview, and then we link that into content at the top here. So that would be through tabs, and within those tabs you can have different content, whether it be things like Power BI or Tableau, those sorts of BI tools that we're all using. Pi Vision, so this is your live information from the Pi system. Another example is Esri, or ArcGIS from Esri. So this could be a mapping tool. It could be live trucks from a mine, or a range of wind turbines or something. We can then bring in other charting information. Again, that could be from Pi, but it could also be from SQL and Oracle and other data sources. So these are just examples. From here, we can drill down through the AF tree. So whether it be through Pi Vision or through the map, I can click on one of these objects in the feature layer here and drill down through that dialog, and so on. So there's lots of different ways to make my way around that tree. The next example is the asset health map. So this is looking at the assets across the fleet, and ranking each of those assets. So for example, a transformer, we're ranking each of those components by say the condition of that component, the performance of the component, the risks, and the analytics. So the condition may be coming from another data source like, say, Maximo or SAP. It could be manually entered. The performance would typically come from AF and calculations. It could be heat rate, that sort of thing. Analytics would be things like predict it and seek. So it's a great way of looking at, for example, a plant status review where we're looking at a range of sites and getting an easy view of the entire fleet and being able to drill down. So from this point here, I can see here, I've got a red icon here, a temperature model excursion. So that's coming up on the transformer. Again, that could be coming from Seek or another tool. And then it can drill down. So if I click on that. So now that's taken me to the transformer in that unit. And from here, I see a holistic view of the transformer with a range of tabs. So first one being a Pi Vision screen. So this is your live information, the temperatures and so on. We can then bring in other data sources like an infrared camera, which is a way of looking at the heat signature on those bushings. We may bring in other data sources like Seek. So this is looking at an expected temperature within the transformer and the actual on there as well. And the same again with predict it. But then to make that decision about what I do with this transformer, I need other information. So this is where I can bring in sources like Maximo and SAP. So what I'll do is the system would run off to those sources and do a query or an API call to those data sources and bring that back on demand. Another example is data entry. So we've all got lots of data entry points, manual data, and Excel is prolific. So what we've got here is the ability to enter into a grid type of form or like a dollar box. And everything you see here in terms of the look and feel and the fields and the high and low limits and so on, all the conditional formatting and icons, everything is configurable. So use cases around the data entry would be things like vibration analysis or manual data collection in the plant, downtime analysis, obviously DGA results and so on. We can also bring in wiki. So this is really bringing in screenshots against that data. So this is structured information that goes into Pi as an event frame. And on the right-hand side is more unstructured screenshots and maybe photos and just commentary and so on. The next example, so again, I'm still at the transformer, so I'm starting to form a bit of a picture of my asset and what I need to do to solve this problem. So now what I can see is my my video camera footage. This might be live, looking at the heat signature. And on the right-hand side would be any alarms that have popped up. So we have an integration with a camera system called Systems with Intelligence, which is what we're linking to here. If I carry on, I'd have integration of things like photos and images, and then things like documents. So these are documents that are related to that asset. This is really useful for when you're in a mobile device out in the field and you need access to your as-built files and your drawings and so on. So what I'll then do is say, well, actually, I need a bit more information. I need to dig deeper into the analytics. So I can click on the Seek. I've got a bunch of shortcuts up the top. Seek is one of those shortcuts. And that will open up Seek already in context of the asset. So I'm already at the transformer. I don't need to re-drill that. And then I'll just go into the actual data and do my analysis. So Seamus has done a great job of demonstrating that, so I won't go into that any further. you can see here what I can do is, now that I've done some analysis, I can bring that through to a tab on the top here, and that will be, for example, my temperature trends and so on within Seek for this asset. What I'll do is quickly jump up to the station level and into some of the alarm capabilities. So we've also got Alarm Sentinel that allows us to bring alarms from the DCS, for example, a high steam temperature alarm. And then we can bring that data from Pi into the trending. So the data on the left is the alarm, the data on the right is the associated analog data in Pi. Downtime entry, so this is for GADS and availability data. So this can be automatically generated when the plant stops, if there's a tripping. Electronic logbook, so this is shift logs, shift handover, that sort of thing. So yeah, so these event frames can be automatically generated by Pi, and ultimately, and also obviously manually entered by the user, and that forms the entry into the shift handover. Power BI, we then use that to visualize your downtime and so on. I'm running out of time, so another quick one, I'll go back up the top there and I'll look at some of the alarm management KPIs. So this is where, let's wait for that to render. So this is a dashboard of all the alarms using the ISA standard 18.2. So this allows us to look at all the alarms across the fleet or per station or per unit and drill down on those areas which need attention. So in this case here, I've got an area of the plant that needs some attention. Click on that and I can start to see, you know, why I've had an alarm issue in that period of time. So hopefully that gives you a rough idea of what we do. So that's bringing data together from a range of different data sources, all based on the Pi system, using AF as the foundational piece, and the alarm management side, using alarms from your DCS and event frames and notifications from AF. Back to you, Steve, and thanks very much.
Terrific, Dave. Thank you very much for that. And yeah, as I said, this is really just if I can sort of a tapas in relation to you know, what meal you can actually get when you want to select some of these technologies. So you know, please feel free after the event to reach out and let us know. Okay, to book in the presentations, we'll have our partner company Texture, and Sean, if you want to just transfer the screen. And I know you look beautiful, but we actually need to see your PowerPoint.
All right, everyone got that now? Can you see my screen being shared?
Yes, thank you.
Fantastic. Thank you, Steve. And also thanks, of course, to the team from ECG Predicted at the start. Pice, I was really interested in your presentation because we're already talking to some of your people about how we can help. And Will and Seamus, thanks for the Seek demo, and great to round up with some Kiwis, Paul and David from Dimension. So thanks to all the presenters for the technical demos today and explaining the features and benefits of your platforms. So Texture is a consulting company that's part of the GTS group, and our core business is to ensure successful outcomes for operational technology and IT projects. The way that we do that is to match the very best operational technology engineering expertise with the best IT project consulting and delivery expertise. So if you like, Texture is the people side of OT and IT, as opposed to the engineering side, which is handled by our parent company, GTS, and of course all our partners such as ECG and Pice, Seek and Dimension. And so the core services that we deliver, as I mentioned, they're not engineering services, they're the non-engineering services that are needed to support and ensure successful projects. And that's our mission, is to support GTS's clients to realise benefits from their projects. And that means excellent project leadership, or project management, as it's otherwise known, strategy and analysis, so the provision of business analysts with specific skills in the right areas, change management. I'm not talking about organisational change management, so rearranging org charts. We're talking about communication, training and the related functions to bed down new systems and make sure that they're properly used by our end users and the people that need to see and act on the reporting from our systems. Of course, quality and testing. One thing that engineers aren't great at is testing their own software, so we provide a bit of extra help with that. And agile leadership. The majority of our clients are moving towards agile models in their project delivery. So we help with providing Scrum Masters and Scrum coaches and the associated agile infrastructure. So really, if we were to draw a Venn diagram, Texture is the third part of that, where the technical platform is joined with the technical implementation and engineering, and it's supported by proper business requirements gathering, and then managing projects through to benefits realisation by highly skilled and experienced people that are not necessarily technical, not necessarily engineers, although they might understand and have experience in the various technical platforms that are used by our engineers, such as the ones we've seen today. So what you can expect from Texture Consultants is that, first of all, they're the best in the business. They're cross-functional A players, so quite often they're very good at both project management and business analysis, or business analysis and test, or change and agile. So yeah, they're by no means one-trick ponies, but all of our people have a laser-like focus and deep industry experience in utilities and mining, so they understand the unique challenges and platforms that are used in the sector. And then finally, we provide them, our consultants, with what we call active delivery support, which is the proactive system of coaching and mentoring and ongoing training that makes sure that their skills are up to date and they have the proper support and coaching they need to do a great job for our clients. That's it. I could do a case study or 10 for you, but we're out of time today, and I really appreciate you listening. And of course, if you need more information about Texture's service offering, let me or Steve know, and we'll be happy to have a chat. Back to you, Steve.
Terrific, Sean. Really appreciate you being very conscious about the time, because we are just 2 minutes over what is classified our standard time, which is great. I'd like to wrap it up for today's session. I'd really like to thank our partners from ECG Chuck, the guys from PICE, from Michael, and I know Sandra is there as well. Thank you very much for your support. Will and Seamus from Seek, Paul and David from our friends across the ditch over in New Zealand from Dimension Software, and Sean from our one of our partner companies, which we form as part of the GTS group in delivering project services. Again, thank you everyone for your time today. I hope you did get some interesting insights into the partner technologies. And remember that what you've seen today is fully integrated in really adding value to the PI system infrastructure that most, if not all of you, currently have. And that's the focus that we have from a delivery perspective, in ensuring that we align with partner technologies which allow you to capture the value and then drive better value propositions out of that data that you currently have. So from all of us that have had an active input in presenting the information to you today, thank you very much for your time, and we look forward to hopefully catching up with you with maybe a much greater detail of presentation now that we've sort of whetted your appetite. Thanks everyone, have a great afternoon, and hope to see you soon. Thank you, bye-bye.